Hello, hello. We continue on the topic of area of triangles, and we derived the formula in the previous video that area of a triangle is a half of base times height. In other words, 1/2 times b for base times h for height. It comes from the related rectangle. As you can see, we have a related rectangle, and we can pack this pink triangle into it. So here is your base times height, but because triangle is a half a rectangle, we would divide it by 2. So one of the very important skills we need to know is how to correctly identify base and height. And hence the exercise number 1 on page 134. So how would we do this? My friends, sometimes it's not so easy to see. We have 3 triangles. Notice they're green color and the shapes are congruent, meaning all 3 triangles ABC. We have A, we have B, C, A, B, C. They are congruent, meaning they are exactly the same. So let's take a look. We can think of a base line AC. Okay? Now let's find the height corresponding to this base. So I'm going to write down base for each of this, and we will practice finding it. Base, base. Now, for the first example, the base is given as side AC. How do we find the height? We have to find the third vertex that is opposite of the base. In this case is point B, vertex B, and we are going to drop the height perpendicular to the base. This is our height H, and it corresponds to segment AD. So height is AD for this example. Now, this is the easiest example when the height is located inside the triangle. Height is inside the triangle. Inside the triangle. Now, let's take a look at the next example. What is our base here? It is given to be side AB. Let's write it down. Side AB. Now, relative to this base, what is our height? Well, we're going to take a look at the base AB, and we're going to find the vertex that is opposite of the base. This is vertex C. Let's label the height and find it. In this example, it's not so easy. We have to drop the height perpendicular to the base. And here we go. Here we go. In this case, we can extend the base AB. And in this particular point of view, the height is CF. So H for height is outside the triangle, outside our triangle. These are not as intuitive. Sometimes you need to rotate your piece of paper to find the base and height. And finally, let's take a look at the last example, where the base is identified as side BC. So it's side BC. Again, how do we correctly find height? From this point of view, we have to look at the third vertex that is opposite of the base. In this case, it's vertex A. And we have to drop the height perpendicular to the base. Let's drop that like this. And again, very strange example, but let's write height is AE, line AE. My friends, your base and your height depend on your point of view. As you can see, we have 3 identical triangles, and depending on your point of view, the base can be any one of the sides. Therefore, it changes your height. What is always consistent is the base is always perpendicular to the height. The height and the base always have a 90-degree angle. I hope you find this instruction helpful because it's not always easy to identify height and base. Let's practice this very simple concept next. How do we find the area in number 2? In example number 2, find the area of each triangle A and B and C. Super easy. Step 1, identify the base. Well, not that difficult. For example A, the base is 6 centimeters. Step 2, identify the height. In this case, the height is one of the sides of the triangle, and it's 8. Therefore, we have half of 6 times 8 is the same as 3 times 8, and it's 24 squared centimeters. Let's take a look at another example. Step 1, identify the base. And the base is given to be 10 centimeters. This is your base, 10 centimeters. Now, not as easy, but definitely doable. Let's find the vertex opposite of the base. Here it is. Here is that vertex. And let's drop the height perpendicular to the base. Here we go. We have a 90-degree angle, and the height is again 8. In this case, the height is inside the triangle, which makes it very easy to spot. Half of 10 is equal to 5 times 8, and we have 40 centimeters squared. Finally, example C, one of those tricky examples. We're giving the base, again, which is 10. Again, we have the same value for the base, and it is 10. How do we correctly identify the height? Well, let's look at the vertex opposite of the base, and here it is. Here is the vertex, and it was right here. Now, let's drop the height down perpendicular to the base. Let's drop it, and we have a 90-degree angle. In this case, we have to extend the base a little bit. Here is that tricky example when the height is on the outside. So let's label this is our height inside, and this is the height outside. But the calculations are still quite easy. Half of 10 equals 5. Let's do 12.2. So we have 10 times 12.2 equals 122, and divide that by 2 gives us 61 centimeters squared. I hope you found this exercise helpful.